Hello and welcome to the video lecture associated with multi-table joins. Ooh, I love this part. It's really get fun. So up until this point we've used two tables. We got into the union query, we did three tables. Ooh. But as we can see, if we look at our relationships window, there are a lot of tables in here. So eventually we're going to have to write SQL. It's going to involve a lot of tables. So this kind of stuff can get a little hairy. So this is what we're going to do. We're going to take this step by step. We're going to use an example where I want to see customer information, order information, and then product information. Now, you should know from IT 117 when we're developing our tables, developing our database, we have this order line table. This order line table is an associative entity. Right? To recall this, so what we have is a relationship between the order table and the product table, which is many to many. So any particular order can be made up of many products. Any particular product can be associated with many orders. So in order to support that in a database management system, we need the order line table. We need an associative entity to link up our orders and our products to support that many-to-many relationship. So we need four tables. We have to use the customer table, join to the order table, join to the order line table, join to the product table. So I've got a nice little figure, right, that kind of shows that in a little bit more detail. If we're back to IT 117 and we're back in our ERD days, here we've got our customer. Alright, so we've got our customer table. This is going to be joined to our order table. We're going to follow our join lines or our relationship lines. So we're going to go from the customer to the order table, and we are going to join on customer ID equals customer ID. Then we're going to go from the order table, we're going to join that to the order line table on the order ID equal to the order ID in the order table equal to the order ID in the order line table. Then, to get the product, we have to go from the order line table's product ID to the product table's product ID. All of these are going to be equi-joins, in this case inner joins. And then the final thing that we want to see is where the order is equal to 1006. Right? We'll start off without the where clause, and then we'll see what the where clause actually does. To give you a different figure, right? So if we had a customer ID, say CX would be equal to CX. The order ID has to be associated with 1006 once we get there, once we actually put that where clause on. Then we're going to go to the order line table and find all the records that are associated with order ID 1006. And then we're going to use the product IDs, which are foreign keys. Again, the order line table is nothing but foreign keys because it's an associative entity. So our product ID is going to get matched to our product ID in the product table, so we could actually see product information. So far, so good. So here we are back at our relationships. The other thing that I wanted to point out that the author does in the PowerPoint slides is the author is using, as you can see here, the cross-product notation. So he's got a comma delimited list of tables, and the where clause takes care of the join conditions. We are not going to do that. We are going to use join notation to do all of this, which again is the much more professional way of doing this. One thing that you might notice that this makes pretty clear is that the rule of thumb when you're joining multiple tables together is for however many tables you are joining together, you should have that many minus one join conditions. So for instance, in this case we have four tables: customer table, the order line table, the product table. We have three join conditions, and you can see that again looking back at the figures. If you look at these lines, we have a line going from customer to order order line, from order line to product. Four tables, three join conditions. So let's get back to Access. So let's write out our select clause. In this case, it's pretty much the same that the author has. In this case, we want to see the customer underscore T dot customer ID. We want to see the customer name. We want to see the customer address. We want to see the customer city. We want to see the customer state. Gotta say, I'm feeling pretty good about spelling customer right these days. We want the customer postal code. Did I get cocky? Nope. Still working. We want to see the order T dot order ID. And again, we have to fully qualify that because that's in multiple tables. We want the order date. We want the ordered quantity. We want the product description. We want the standard price, which should be the product standard price. Actually, the SQL that the author has in the book isn't going to work. And then we're going to see the extended price by putting together the ordered quantity times the product standard price. And we should alias that, since it's a calculated column, as extended. See? Look, I got cocky. I spelled extended wrong. Now, the from clause. So we start off with our from clause, and we'll put the customer table together, right? So customer T, inner join order T on the customer T dot customer ID equals the order T dot customer ID. Okay, so now it starts to get a little bit more complicated. We've taken care of one of the joins between the customer table and the order table. Now we need to put the order table joined onto the order line table. So we're going to start using order of operations. We're going to start surrounding things with parentheses. So when I surround that, this part right here, this is handling, right, the join between customer and order. Now we're going to put in another table. So we add another parentheses in front of the customer. And then what we're going to do is we're going to inner join that, right? The customer and the order now get joined to order line. Order line T. And then we use the on clause. So, you know, this is where a lot of students start to get confused when they say, all right, wait a minute, there's nothing in front of the inner join. There is something in front of the inner join, the other join condition. So we've got those two tables already being joined. So think about those two tables, the customer table and the order table, already being combined. Once they're combined, now I'm going to take what has been combined in memory and I'm going to join that to another table. In this case, that's the order line T table. And it's a join condition. So we're going to have the order T dot order ID is going to be set equal to the order line T dot order ID. I'm going to close the paren on that. So now see how the parens are surrounding what's going on, right? So now we're going to do one more. So we're going to go back up to just after the from. I'm going to put in another paren because we are going to join that, right? So I need another inner join to the product table. Product T, and we're going to join that on the product T dot product ID is equal to the order line T dot product ID. We're going to close the paren on that. So you see how that works. We've got the customer being joined to the order. We have our join criteria for that. Then that combination is inner joined to order line T, and that has its own join criteria. And then that is inner joined to product T using that join criteria. So far so good. Now cross your fingers, you hit run, and I spelled order quantity wrong. Oh, ordered quantity. Well, you know what the author spelled it? Nope, the author spelled it right. I spelled it wrong. What did I do? I did that twice. Ordered quantity. I think I said it, I just didn't spell it. So here, our set is our 39 records of all of customers with their orders that have orders that are associated with products. So again, we have 39, which is different than the 59 orders that we have. So there's something going wrong there, which we might have to investigate somewhere down the line. Likely we have orders that either don't have order lines, or we have order lines that are not associated with products, one way or the other. This video is going a little long, but this is a very, very complicated thing to do. So, as you can see, here are all our order IDs, right? Our customer IDs, and we can see all of the information. It's a very, very powerful query we just put together. But now what we want to do is we want to see everything for the order ID equal to 1006, which in this case isn't going to give us anything. So why don't we do this? Why don't we say that the order ID is 4, right? So we go back into our SQL. Whoops, didn't want to do that. To SQL view, I'm going to put in a where clause. So if we do order ID equals 1006 and we run that, nothing's going to come back. Oh, and since order ID exists, we have to use that in more than one, since it exists in more than one table, we have to fully qualify it. On that, we get nothing back. So change to 1006. Let's get back into SQL view. Change to 1006 equal to 4. Run that, and there you go. And we've got our unit price times our extended. So you can see that our ordered quantity is 0. That makes no sense whatsoever. We have an order that has why did we have an order for 0 entertainment centers? That's our big ticket item. That should at least be a 1. But you can see the extended price is actually calculating out our ordered quantity times our unit price. So hopefully that was a very good learning experience for you. Hopefully you get the idea of what you need to do when you are joining multiple tables together, and hopefully you're getting an idea of how complicated this really can get. So, obviously I've been talking too long, so that ends my video on multi-table join conditions. Now I'm going to get something to soothe my throat.